lecture series on communication theory and techniques. In today's class, we will see the average information content, that is entropy, of a symbols in a long independent sequences. Let us consider the source alphabet S, which is emitting symbols S1, S2 till SQ with the probabilities of P1, P2 and P2 respectively, and consider a long independent sequence of length L symbols. So this long sequence then contains P1 into L number of messages of types S1, P2 into L number of messages of type S2, and PQ into L number of messages of type SQ. It means in order to find the average information content, in the last class we have seen that is self-information, which is inversely proportional to probability. Suppose if you know the probability of any symbol which is occurring with certain probability, you can easily find the self-information. Here, if you want to find the average information content, then you should also know one more factor, which is the length of the message. So here what is considered is a source which is emitting certain symbols S1, S2 till SQ, and each symbol has its own probability of occurrence, that is P1, P2 and PQ, and the length of the sequence is L. So when such case is existing, so in order to find the average information which is present in the source, we need to use the formula of an entropy. So to get that formula of an entropy, we need to find the P1 into L number of messages of type S1. So S1 will have P1 into L number of messages. So here what is done is the probability of the first symbol and its length has been multiplied. Similarly, P2 into L number of messages of type S2. Similarly, you take it till the last value, that is PQ into L number of messages. Next, we already know that the self-information of symbol S1 is given as I1 is equals to log base to 1 by P1 bits. But now we want to find the average information, and the length of the message is L. So in that case, if it is P1 into L number of messages of type S1 contains P1 into L log base to 1 by P1 bits of an information. So when you have the source of type S1, then there will be P1 into L number of messages which will be present. So this is the case when we want to find the average information. Similarly, take for the second case, P2 into L number of messages of type S2 contains P2 into L log to the base to 1 by P2 bits of information. So similarly, if you find it for the final last value, that is PQ into L number of messages of type SQ contains the PQ into L log to the base to 1 by PQ bits of information. So this is the information now which is present in PQ into L number of messages. Here what is done is, I repeat this case, we are finding the average information for which we need to take into account the probability and the length of the message. And when we try to find the average information, that time the formula of the information content will be P1 into L times, that is the probability of that symbol, into length of the symbol into log of 1 by P1 bits of information which will be present. So now let us find what is the total information which is present. So the total information is given as P1 into L times log of 1 by P1 plus P2 into L times log of 1 by P2, this is always base 2, plus till you can take PQ into L times log of 1 by PQ. Remember, here the L is the length of the message and P is the probability of each symbol. So when I take L common from these terms, so L summation I is equals to 1 to Q, pi log to the base 2 1 by pi. So here we can see that this is the total information, and if I divide it by L, if I take L on the left hand side, so this will be I total by L. It means the total self information divided by length of the message will give me the average information. So the average self information is given by I total divided by L. Here in this formula, I total you keep as it is, take L on the left hand side, it comes in the denominator. So that will become your average self information. Average because you are dividing the total information divided by the length of the message. So that itself is the average information, which is entropy, which is written as H of S, which is equals to I is equals to 1 to Q pi log to the base 2 1 by pi. So its unit is bits per symbols. So the average self information is called as an entropy of the source, which is denoted as H of S. So if you want to find, I will give an example for finding the average. Let's say if you want to find your average, or if you want to find your CGPA from first to fourth semester, what you usually do is you take first semester SGPA, then second semester SGPA, third semester SGPA, and fourth semester SGPA. You add all of them and later you divide it by 4. So when you do that, you will get the average percentage or the CGPA of last 4th semester. So this is how we find the average value. Take the total value and divide it by the length or the number of times it is occurring. Now let us see the next definition, that is information rate. Average source information rate is defined as the product of the average information content per symbol and symbol rate RS. Here RS is the symbol rate. So the symbol rate RS is the fixed rate at which the symbols are emitted by the source. So as I told you, if you consider a source which is emitting symbols S1, S2, it emits at particular rate with certain probability. So the rate is called as RS. So the information rate, that is denoted by capital RS, is given by RS into H of S. So to find the information rate, you need to first find the entropy and the symbol rate. If it is given, use that and try to find the total information rate. So let us see with one example how to find the entropy and the information rate. Here it is given a discrete source emits one of 6 symbols once every millisecond. It is millisecond over here. The symbol probabilities are 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32 and 1 by 32 respectively. Find the source entropy and information rate. So entropy, we already know it is H of S, summation I is equals to 1 to Q. Here Q is 6 because we have total 6 symbols probabilities 1, 2, 3, 4, 5 and 6. So I is equals to 1 to 6. Each probability log to the base 2 1 by pi. So let us find the entropy. So for the first probability is 1 by 2. So substitute 1 by 2 log to the base 2 1 divided by the probability. So the probability is 1 by 2. So 1 by 2 comes in the denominator. So the 2 will be in the numerator because the denominator of the denominator will become the numerator. Similarly, we have next probability which is 1 by 4. So use the formula 1 by 4 log to the base 2 4. Similarly, calculate for 1 by 8, 1 by 16. Here, if you see, there are 2 symbols which are having probability 1 by 32 and 1 by 32. So we have taken it as 2 times of 1 by 32 log to the base 2 32. Remember, when you are calculating information or entropy, use log to the base 2 always. It's must. So when you calculate this, when you add the total content, information content, you will get 1.9375 bits per symbol. This is the unit for the entropy. Next, we need to find the information rate. That is, RS is equals to symbol rate in H of S. H of S is already known to us, which is 1.9375, but RS is not given. So for that, we need to check the numerical once again. Here, if you observe, the discrete source emits one of 6 symbols once every millisecond. Means it is emitting symbols at every millisecond. So one symbol per millisecond. Okay, so if you take the symbol rate, it is 10 to the power of 3 symbols per second. So RS is equals to 10 to the power 3 into 1.9375. So when you find out, the RS will give you 1937.5 bits per second. So this is your information rate. So one of the important concepts what you need to understand in this particular unit is what is self-information. That is, Ik is equals to log to the base 2 1 by Pk. So if you have source which is emitting certain symbols with certain probabilities, so use this formula to find the information which is present in the particular symbol. So that is what we usually call as a self-information. And remember, the probability, if it is very low, then the information content is going to be very, very high. And next concept is the average self-information or average information content, or you can also call as an entropy, which will be calculated using this formula. Okay, so the average information will give you the total amount of information which is present divided by the length of the message, or the number of times the symbol or the message is occurring or emitted. So when you do that, you will get the average information. So in the unit number 1, you will study a term called as an expected value. Okay, that is what we usually call as an average value. Okay, so this has a lot of importance in the communication system. Suppose if you want to transmit, if you want to know how much information is being transmitted from a point A to point B. Okay, so that is where entropy will help us in finding out or giving us the insight of the average content. Similarly, when we study a few more concepts in the next semester, that is Shannon's entropy, Hoffman entropy, so you will get a clear idea that how these concepts are used in the communication. So that is self-information and entropy. In the next semester, we will be going through a few more concepts, in detail on this particular topic. So where we will see different types of techniques. It might be a Shannon coding technique, Hoffman coding technique, where we will find the average information, and on that we will be making a lot of decisions in the communication system. So this concept is going to be very, very important. It's a fundamental concept for the communication system, and especially in the information theory, which has got tremendous use in the communication system, in the especially if I have to name it particularly in the radar system and in the spatial aircraft system. So this concept has got a lot of application. So that concepts we will be going through in detail in the 5th semester in detail. But for time being, try to understand the meaning of entropy and the self-information. In the next lecture, we will see few more concepts related to this topic, and we will solve few more numericals on the average information content.